So the first chapter in this semester will be chapter 20 on electric charge, force, and field. Electric charge is a fundamental property of matter. Positive and negative charge. Protons have positive charges, electrons have negative charge. So then, is charge really a continuous quantity? In other words, can charge have any value? Charge is not a continuous quantity. It's actually, it always has the charge, the amount of charge is always multiplied by some quantized number. And what is the electric force between two charges? Coulomb found that, charges, the electric force acts on charges. The amount of, the magnitude of electric force is proportional to the multiplication of the charge, each charge, Q1, Q2, and also inversely proportional to distance squared, which is very similar to Newton's law, universal gravitational force. And you can use superposition of the vectors, but it's very complicated. Usually, in this case, we can measure, in principle, we can measure, we can define an electric, instead of, every time we calculate the electric force, we find the electric field on this point, every point of the space, and the multiplied the electric field by the charge gives the total force. So electric field, we learned the gravitational field in General Physics 1, which is very similar. Electric field is the difference between the force concept and the field concept is force always is action reaction. We imagine a unit charge, 1 coulomb, exists at a point, and then the force acting on that imaginary charge is the electric field on that space. Electric dipole is just 2-point charges, an equal magnitude but opposite sign, very close to each other, like this. This is electric dipole. Plus minus charge, equal charge but opposite magnitude, equal charge, equal magnitude but the opposite sign, and very close to each other. This is what we call dipole, because there's two charges, equal magnitude and opposite sign, but because even if this is charge neutral, because they are not exactly at the same position, it results in some electric field. Electric field comes out of this positive charge and then goes back to the negative charge. Because of the spatial separation, it generates some electric field. Electric field, not the summary of the chapter, but the electric field. So matter in electric field, we learned that electric force acting on charge Q is, if we know electric field, then it's multiplied by electric field, acting on that charge. Force acting on the charge is charge times charge multiplied by electric field at the position. Electric force accelerate is same thing. Electric force accelerate the mass of Q by Newton's second law. And dipole in uniform electric field experiences torque that tends to align the dipole moment with the field. We learned a lot of stuff. Electric charge, right? Electric charge, and then electric force obeys superposition principle, meaning the forces due to individual charge sum vectorially. It's vector, like electric force. Electric field describes force per unit charge, similar to gravitational force, describes force per unit mass, right? Point charge experiences force F equals QE in an electric field. Dipole experiences torque in electric field and force if the field is not uniform. And the torque tends to align the dipole parallel to the electric field. Thank you.